Alright guys, welcome to part 2 of lesson 1.2. We're in Math 0314. We're going to be talking about applications involving percent in principal and interest. So let's see here. So Miguel invests $10,000, one account at 4%, the other at 7%. If the portfolio grew to $10,625, how much was invested at each rate? Okay, so these are complicated problems. My advice is not, sorry about that. My advice is to use a chart to do these problems. Yay! Okay, so how does a chart work? Well, you have, you're investing two things, right? So we'll call it invest 1, and then we'll call it invest 2, and this means, you know what, investment, I can fit ment in there, investment 1, investment 2, and then we'll squeeze in total here, and going down, we have the amount, there's some rate, and maybe I'll write total investment here. And here we're going to go total value. Okay, so what am I doing here? Well, first let me put in the values correctly. So he invests $10,000, right? Is one account at 4%, the other at 7%, right? So if you invest $10,000, would that be investment 1, investment 2, or the total investment? Clearly that's going to be the total investment, 10,000, right? And then we have one at 4%, so the rate would be 4%. Notice 4% is 0.04, because 4 over 100 is 0.04. And the other one is 7%, so 0.07 here. Hopefully that's not too bad. And the portfolio grew to 10,625. So that would be, once we put it all together, we get 10,625 here. All right. So what am I doing here? Well, I like to put things in this chart because it organizes that what we're trying to do fairly clearly. Okay. So going across in this chart, we're just going to add, right? So if I took whatever I have invested, I don't know what's invested at. Investment 1 is how much money I put in there. But if I did, and if I knew how much I was investing in investment 2, and I put that in there, and added them together, that would have to equal to the total investment, which is 10,000. So it makes sense that we add across. Same thing with the total value. If I multiplied what I made off of the first one and put it here, and then the second one and put it here, and then added them together, that would give me the total amount of money that I made off of them, right? Now, there's two things that we want to do here first. So adding across, sorry. Now, rate is the one exception, because obviously if I add this rate and this rate together, it doesn't give me the overall rate, right? The overall rate would be some value between 4% and 7%, right? Because part of it's at 4, part of it's 7, so that makes sense. So we want to make sure that we're clear that when we're adding across, we do not add across for rate. Now when you multiply, when you go down on this chart, you're going to multiply, and that should make some sense too, because if we have an amount, right, we multiply by some rate, this will get me how much I've made off of the interest, right? Now, in this particular problem, and I hope you caught on to this, there is a catch here. I actually have to put 1.04 and 1.07, because what I'm getting here, right, if I want to get the total value, I want to get how much I've made off the interest. So let me try to make this more clear. If I have $100, and let's say I make 20% off of my $100, right, that would mean I would take the $100, and if I add 20% of 100, this would give me how much money I would now have, which is 120, right? But what we can see here is if I factor out 100, I'm left with 1 plus 0.2. or simply 100 times 1.2, or 1.20, right? Which, if you multiply, that'll give you 120%. And what this means is the 1 here means the initial amount, the 100, right? And the 20% means how much you made off of the interest. And when you put it together, you get 120%. So whenever there's a percent increase, we can put a 1 in front of the percent, and that would be it. If this was a percent decrease, then we would be subtracting from 1. So in other words, this would be 0.96, and this would be 0.93, because there would be some sort of depreciation, right? So the other thing you could do here, if you wanted to, is I could rewrite this as just 625, and then I wouldn't have to put a 1 here, and I wouldn't have to put a 1 here, okay? Right? Because that's how much I would make off of it. But I don't think that is as clear as what I originally had written, so let me go back and let me rewrite the way it was written before. And actually, let me erase this because I'm going to need some space here. Please hold while I erase. You hit a button over and over again, sometimes you feel like you're hitting something else. Okay, and actually, there we go. Okay, so now I'm ready to rock and roll. So hopefully that makes some intuitive sense. Go across, you add. Going down and multiply. Just remember you can't add across for the rate. Okay, so what am I going to do here? It says it wants me to know how much did I invest at each rate. Let me use a different color here. Let's go with gray. Okay, so what I'm going to do is I'm going to call this value here x, and this one here is going to be called 10,000 minus x. And I want you to stop for a second and ask yourself, why does that make sense? Why, if I call this x, can I call this one 10,000 minus x? And the answer is, well, we said you add going across, right? So notice that x plus 10,000 minus x gives me just 10,000, right? And so that's why that makes sense. Now, what I actually did is if I say x plus y is 10,000, if I want to know what y is, I just subtract x from both sides. So y equals 10,000 minus x. And why would I rather use 10,000 minus x as opposed to creating another variable? Well, if you can keep everything in the same variable, the problem becomes a lot easier to tackle, right? If I have more than one variable, I'm going to need multiple equations, and it just makes things more complicated. So let's keep it as simple as possible, because things are already kind of complex. So hopefully that makes sense. Now what can I do here? Well, I said you multiply going down, so this is just 1.04x, and this one here is 1.07 times 10,000 minus x. And what can I do with this? Well, we know that going across we add, so we just, this plus this will equal to that value. In other words, 1.04x plus 1.07 times 10,000 minus x is going to equal to 10,625. Okay, and now we solve this. Now, my natural inclination is to multiply through by 100 to get rid of the decimals, but these numbers are already super big, so I'm just going to go ahead and just solve it by just distributing, and we're going to get some ugly numbers here. So we get 1.04x plus 10,700 minus 1.07x equals 10,625. And then I'm going to look at this and say, hey, what can I put together? Well, clearly we can put these together, and we'll end up getting negative 0.03x and almost out of space. And so now what I'm going to do is I'm going to subtract 10,700 from both sides, so we're just solving it like a regular equation. And it's good that we get the other both sides to be negative, right? So they cancel out. Wouldn't make sense if the answer didn't come out that way. And to finish it off, I'm going to divide by negative 0.03. And this is going to give me x to be 2,500. Which means that I originally had 2,500 in this account, right? Which means that this other one has to be 7,500, right? Because they have to add up to 10,000, right? 25 plus 75 is 100. So there you have it. That's all there really is to it. Practicing with this chart, I think, is going to make your life a whole lot easier. Let's look at the next one. So pause the video, try it. It's pretty much the same thing. Hopefully you'll be able to do this on your own. So hopefully you've had a go at this, and now we can do it together. Let's see here. We have Jonathan, who borrows $4,000. One account charges 7%, the other charges 1.5%. After the interest period, Jonathan pays $225 in interest. Find what is borrowed in each account. Okay, so I basically left the chart more or less the same, and we're just going to substitute in values. So we have here that he borrows $4,000, right? So the total investment is going to be $4,000. Hopefully that's correct. And then one account charges 7%, so I'm going to put 0.07, and the other one charges 1.5, so this is 0.015. Be careful. It's very easy for people to put in 7 for 7% or 1.5 for 1.5%. But if it's out of 100, you're dividing through by 100, and you'll get those numbers. If you have any doubt, just literally type in 7 over 100, and it'll give you the decimal. And then type literally 1.5 over 100, and it'll give you this decimal. So what's the other value? They tell us how much is borrowed. The interest he pays. He ends up paying $225. So the total, it's an investment here, but the total, I almost want to say total interest, whatever, you get the idea. It's $225. Now, one thing you'll notice here is you're like, Mr. Anderson, I'm confused. Here I put 1.04 and 1.07. Here putting 0.07, 0.015. Why did I not put the 1 in front? Because 225 is the amount that he has to pay in interest. So we're looking for how much is left over. So you have to use a little common sense here when you're going through and you're solving these problems, right? You can't just substitute the numbers. You need to understand the context of the problem. So, but again, if this is x, this is going to be 4,000 minus x. And so we said going down we multiply. So this would be 0.07x. This will be 0.015 times the quantity 4,000 minus x. And just like the other problem, we add these two together. It should give me 225. So we're left with 0.07x plus 0.015 times 4,000 minus x, and this should give me 225. Again, if you want to, you can multiply through by, I would multiply through by 1,000 if I wanted to get rid of the fractions. You would most likely in a situation like this always be asked to use a calculator to solve it, so I'm not going to stress over these. I'm just going to distribute this and just type in the calculator. So for the first part, I'm going to end up getting 60 minus 0.015 x equals 225, and we still have the 0.07x here. By the way, 0.015 times 4,000 shouldn't be hard because just think about 15 times 4. And you know what 15 times 4 is off the top of your head, whether you realize it or not, because you know a clock has 60 minutes total. If you divide by 4, each of those are 15 minutes, right? Just keep cleaning it up. So let's do this. Let's consolidate terms. Let's put the 0.07 and the 0.015 together. So I'm really just doing 70 minus 15 which is 70 minus 10. 60 minus 5 is 0.05. So this is 0.055x plus 60 equals 225. And then we're going to, I'm going to use yellow, subtract 60 from both sides. Here I always like to see if I'm doing it right, because if the signs stay positive, then I'm right. If you get one is negative, one's positive, you know you did something wrong, because you can't have a negative amount of money. So 225 minus 60 is going to be what? 5. This is 12. So this is 6. This will become 165. And finish it off. Let's divide through. And we'll do this in brown. So divide through by 0.055. 0.055. And this will get me 30,000. So if this is 3,000, this has to be 1,000, and we're good to go. So hopefully that makes sense. On to the next question. How many liters of 40% antifreeze must be added to 4 liters of a 10% antifreeze solution to produce a 35% antifreeze solution? So just like before, pause the video, give it a shot, and we'll talk about it. So let's assume that you've given it a go. Let's see what we got to do here. So it says how many liters of a 40% antifreeze. So how many liters of a 40%? So we're looking for one of them. I can call the 40% either antifreeze 1 or antifreeze 2. I'm going to put it under antifreeze 1. Must be added to 4 liters. So now they're telling you have 4 liters of a 10% solution to produce a 35% solution. Okay. So one thing to notice here, we didn't talk about this value here in the previous question, but because 3,000 is closer to, you have more values, you have more of 3,000 at 7% than you do of 1,000 at 1.5%. Whatever this value is, it's going to be far closer to 7% than it is to 1.5%. In fact, we can actually figure it out real fast, right? So we know that we multiply going down, so 4,000 times this gives me 225. So all I have to do is 225 divided by 4,000. And that comes out to be roughly 5.6% or 0.056. It's not exactly 0.056, but it's close enough to 0.05. It's 0.05625. But you can see you're way closer to 0.07 than you are to 0.015. And I'm not going to calculate it, but the same thing would be true here. You're going to be closer to the 1.07 or the 7% than you are to the 4%. Whatever this value is. Okay? So just by looking at this, I know that this number here, whatever x is going to be close, is going to be bigger than 4. Automatically can tell you that. It's going to be, well, maybe not significantly, but it's going to be a lot closer to 4, a much bigger number than 4, because you have 40% here and only 10% here. And so 0.35 is way closer to 40% than the 10%. So these are little things that if you pay attention to, you can say, hey, do my numbers make sense? Okay. Let's see, do we have any other pieces of information here? Nope. That is it. So what do we know we can do on the chart? Well, we know going across we add, so that's x plus 4. We know we multiply going down, so we have 0.40x. And this is going to be, I'm going to write it out, 0.4 times 0.10. And I'm going to squeeze this in. This is 0.35 times x plus 4. Okay, so hopefully you're catching on to the pattern now. We add going across, so this is simply 0.40x plus, where are my parentheses? What is that? I wrote 0.4, it should be 4, my bad. So 4 times 10% is 0.4. See, my mind is working faster than my hand. And then here we have 0.35 times quantity x plus 4. And we just keep going. We keep cleaning it up. So The next move is to distribute. So I'll distribute this 0.35 into both of these. 0.35x plus, and then we're going to do 4 times 0.35, which is 1.4, equals 0.4, 40x. Okay, and so from here, go to orange, subtract 0.35x. So I'm going to put our x's together. This will give me 0.05x. Be careful, don't put 0.5x. Times 0.4 equals 1.4. And then we will, let's go green, subtract 0.4. So 0.05x equals 1. And to finish this problem off, we're going to divide by 0.05, which should give me 20. And there we have it. So, way more intimidating looking than it is to actually do it. Okay, let's look at the next one. Find the number of ounces of a 30% alcohol solution must be mixed with 10 ounces of a 7% to obtain a 40% alcohol solution. So, pause the video, give it a shot. Very similar to what we just did. Okay, going to assume that you've given this a go. Let's talk about it together. Find the number of ounces of a 30% alcohol solution. So just like the other one, it says how much of a 30%. So it must be mixed with a 10 ounce. So 10 ounces of a 70% in order to obtain a 40%. Okay. So again, notice what I did here, and I didn't mention this before, but this is actually how I'm doing these problems actually for the first time. I don't practice beforehand. Just go and do it. And you'll see what I actually like to do. As I read, I fill in the chart, right? Actually, obviously beforehand I make the chart just to save some time, but read through, and as you read through, just start labeling what you know and what you don't know. One other thing I want to stress on the last problem, I forgot to mention this, right? This turned out to be, 20? And like I said, it's going to be a significantly more larger number because you have 40% here and 10% here. This 0.35, what it really is a weighted average between these values and this value. In much the same way that how you calculate your grade by using a weighted average. So, when we look at here, if this is 0.4, 0.3, 0.7, 0.4 is closer to 30 than it is to 70, but it's not too much closer. So this number, this x value, will be bigger than 10, but it won't be as much as a significant difference as the previous question. So it's good to know. From here, it's more or less the same as what we did before. We're going to add across, so that's x plus 10. We're going to multiply going down, that's 0.3x. This is 0.70 times 10. And this is going to be 0.40 times x plus 10. And like we've said before, this adds up and is equal to this. So this gives me 0.30x plus, I'm just going to go ahead and say 7 equals 0.40x plus 10. So keep going. Here, hopefully this is easy for you. Distribute this out. So this is 0.40x plus 4 equals 0.30x plus 7. What I'm going to do here is I'm going to move the 0.30x over here just because it'll keep it positive. And then I'll subtract 4. And to finish off in yellow, divide through by 0.1, which just means that this, ran out of space, the x is going to become 30. So let's see if that makes sense. So I said it would be bigger, but not significantly bigger. And I mean, obviously this is 16 and this is 20, but because the numbers are bigger, that's why we have that sort of discrepancy. But proportional wise, it's not that much bigger. So hopefully that makes sense to you. And let's see the next question. Okay. Actually, you know what? We really don't need... Well, I'll do them anyways, just in case you see them on the homework. Let's take a look at number 5. Mr. Anderson runs 1 mile per hour faster towards math problems than away. If it takes him 3 hours to run towards the problem and 4.5 to run away, what is his speed running back? Okay, so same idea here. We're going to go, I'll put towards, we'll go back, so towards the problem, back, and then we have the total. The only difference on the going down, we have well, let me put it this way. Distance is equal to rate times time. So we have the time, we have a rate, and then we have a distance. Okay, so let's see here. Mr. Anderson runs 1 mile per hour faster towards, so he runs 1 mile faster. It's weird talking to myself, referring to myself in third person. So if this is R, this is 1 plus R. Let's see if that makes sense. Runs 1 mile faster towards the math problem than away. So if you're going faster, actually I need to switch that, right? This actually has to be R plus 1. Why? Let's think about it. So if I run at 10 miles per hour towards a problem, then running, if I'm faster, then it would be towards it. Oh, my bad. No, this is R plus 1. This is R. Because if it was, if running back was, let's say, whatever I said, 10 miles, this would be 11. So hopefully that makes sense. If this was 10, this would be 11. Right? So it's faster. And then it says, if it takes him 3 hours to run towards the problem, so it takes him 3 to run towards and 4.5 to run back, what is the speed running back? Okay. So what do I want to do here? Well, what you need to realize is whether I'm running towards the problem or away, the distance is the same. So 3 times R plus 1, again, multiply going down here, right, is the same thing as 4.5R. And that's all you got to solve. So this is a special situation. If I distribute, I get 3R plus 3 equals 4.5R, and you just solve. So subtract 3, subtract 3R, for 3 equals 1.5R. Finish it off, divide through by 1.5, and that's going to give me 2. R is 2. So you can see here, and I'm almost out of time here, but we can see that all what you do is you substitute in the values. This is a special case because the distances are the same. So you need to read carefully and realize what's going on here. I'm just about out of time. I had one more question, but I think this is sufficient for you to understand. If you want, take a look at this question. I will go ahead and make one more video and solve this on a separate video. And we will talk about that on the next video. So hopefully this is making more sense. This is tough. So if you're struggling, don't beat yourself up. Try your best. And then once we finish chapter 3, maybe this will make more sense. I'll see you guys when I see you.